Okay, I'm going to take you through this practice chapter 6 test. Make sure you understand every single question. Okay, re-watch this, check your answers, practice more, go back to the notes, make sure you understand all these questions. So the first six were solving equations with logarithms, or where we have to solve where our unknown is the exponents, where we're going to have to use logs to be able to solve. So we learned in our notes that we can apply the definition of a log. Okay, we have to realize it's base 10, so it's a common log. I don't see a base, I don't see a little number here, so it's understood to be base 10. So it really means 10 cubed equals 9x minus 2. And to help us, we learned a technique called exponentiating. So I can put a 10 right here on this side. That will wipe out the log base 10. So whatever you do to one side, do to the other. So we're basically saying exactly what I said earlier, where it's 10 cubed equals 9x minus 2. Okay, again, that's the definition of log applied to this equation. And so now I just asked my calculator, what is 10 cubed? It's going to be 1,000. And then it's a two-step equation. Okay, so then I have to add a 2. So I'll write it over here. It's going to be 1002 equals 9x. And then the last move, divide by 9, and you're going to get 111.3 repeating. Okay, so 111 and a third is your answer. Okay, hopefully those steps make sense. For number 2, we talked again about this. If you see multiple logs on one side, we must condense. So star this. You can't solve this. You can't exponentiate. You can't use the definition of log until it is a single log. So since it's a plus, all we have to do is multiply 4 times x minus 9. Okay? So again, this is base 8 this time. So it's going to be 8 squared equals this. Okay, to help us understand that, I'll do this exponentiating. That wipes out my log. I'll distribute the 4. We get 4x minus 36 equals. Now, make sure you realize it's 8 squared. So we get a 64. So 8 is my base, 2 is my exponent. We get 64. And then from here, it's super easy to solve. We add 36, we get 100. We divide by 4, and you get an answer of 25. Okay? Not hard. Okay? This one, I'm ready to rewrite this. It's base 4, so it's really, this time, again, I could put a 4. I'll just use the definition of log this time. So my base is 4, my exponent is a 0, and it's going to equal this. So it equals x squared minus 7x plus 11. Okay? And it's your job to know that 4, 0 is a 1. So this really is a 1. So I'm going to just simply subtract 1. So I get 0 equals x squared minus 7x plus 10. And if you see this on your test, I promise it's going to be very easy to factor. So if you see a problem like this, expect to be able to find the answers very quickly. So I'm setting this up. I know it's minus minus, ways of getting 10, 10 and 1, that won't work. But a 5 and 2 agrees. It would add up to that negative 7x. So if these are my factors, 5's an answer, and positive 2's an answer. Okay? For this one, it's an ln. ln is log base e. Okay, got to know that. Hopefully you've seen that before. So my base is an e. So really what this really means is e cubed equals 4x plus 6. Okay? And then it's going to take us 2 moves. And I'm not going to pick up my calculator until the end. So I'm going to just keep it as e cubed. But we have to subtract the 6. And then once we do that, we have to divide by 4. Okay? So this will be a decimal. Let me grab my calculator so you can see how I'm going to type this in. So I need to ask the calculator to take e, so second ln, cube it, and then push away so that we subtract our 6. I'll hit enter, and then I'm going to divide by 4 right away. So I don't really need to copy down that answer, but then this answer is about 3.52. Okay, that's our answer. Nothing hard there. This one now, you will see this, and I need you, please do not divide by 3. Okay, if your base is 3, you cannot undo it by dividing. So what we learned in class, we want to isolate this base. 3 is being raised to some power. So the first move is to add 8 and make it 100. Okay, this is why we learn logarithms. To answer the question, 3 needs to be raised to what power to be 100? Well, that's what logs are for. Okay, this is exponential form. I can rewrite this as a log, which means log base 3 of 100 equals my answer. Okay, so we could do log base 3 on both sides. So like another way I showed you this on a test, if your base or on in your notes, I have base 3, I could take the log base 3 on the left and then do it on the right, and that's where you'll see log base 3 of 100. And of course, our calculators have no trouble telling us that answer. So I need to type in the 3, which was my base, and my number is 100, and we get about 4.19. So X is about 4.19. There you go. Okay. Now for number 6, please be careful. That 6 is not your base. Okay. E is your base. So since it's 6 times your base, I want to divide first. Okay. We must divide by 6 first. And then we get E raised to some power, which is going to equal a 4. Okay. So I need you to realize that's what we're doing. And then all I needed to realize, the next thing to realize is this is why we learn ln. Okay. To figure out what E needs to be raised to equal 4, I simply, and again, I could take the ln of both sides, X equals the ln of 4. Okay. I asked my calculator, hey, calculator, what's the ln of 4? It tells me about 1.3, and I'll round to 9. Okay. And then another thing I'll show you, just so you can understand this. Since I already have this answer stored in my calculator, I'm going to hit 6 second ln, and I'm going to raise it to this power. So second answer. Okay, so if you would put this in for your X, this better tell us 24. If it doesn't, we messed up, but it of course checks we have the correct answer. Okay, so that's 6 examples of solving equations involving logarithms. There's plenty more in our notes. There's plenty extra practice that we did. Make sure you come into the test knowing how to solve the basics of solving equations like the ones we just saw. Okay, the rest of this on this page, nobody should get wrong. Our calculator can do these for us. If you need help, just type it into your calculator. So all we need to be able to do is hit the math key. So we need to find math key, and then type in your base, type in the number. In this case, I know it's -2. I know 7 needs to be raised to the -2 to give us the answer. Okay. For this one, it's not a nice answer, so I'm forced to use the math key. So for this one, I hit log base again, put in my base of 5, put in my 175, and when it's a decimal, I would like you to try to round to 3 decimal places just to be a little bit more accurate. 3.209. Okay, that's 3 decimal places. Okay, if you wanted your calculator to round, remember I showed you this mode. You can change the float to whatever you want the calculator to round to. So if I wanted the calculator to round to 3, I can highlight 3, and it's going to tell me the 3 decimal places. Okay, so just keep that in mind. This one won't even type in the calculator. The answer is 1/2. I know 9 needs to be raised to 1/2 to turn it into a 3. Okay. And same thing for this. If my base is a 2 and I want it to come turn out to be a 1, I would have to raise 2 to the 0 power. Okay, again, calculator would tell you those, so don't get that part wrong on your quiz. Okay, the next part, this is nothing new. I quizzed you on expanding and condensing, so we should be able to quickly do these. We learned that if you're multiplying, you're going to separate with a plus sign. If you're dividing, you're going to use a minus sign. Okay, so I see 3 parts to this. I'm going to have to write ln 3 times. So I'm going to save a step. So instead of writing a to the 7th, I'm going to put the exponent out front right away. Okay, since I'm multiplying, I'm going to use a plus. I'm going to put the exponent of 10 out front right away, and I'm going to take the ln of c. We have a b to the 5th in the bottom, so I need a minus sign. I'm going to put the 5 and then ln of b. That is how we expand, okay? And just imagine if I gave you that and told you to condense it. I need you to know why a to the 7th, c to the 10th, and b to the 5th is on the bottom. So these 2 things would be up top, b to the 5th on the bottom because of the minus sign. So that's what I'm asking you to do over here. I am asking you to condense this. So since I only see plus signs, I won't have a division, okay? It's just going to be b cubed times c to the 4th times a to the 1/3 power. Now you can put parentheses. It's not wrong not to have the parentheses. It's understood that this is all together, okay? So we already quizzed you multiple times on condensing and expanding. And this section, we already had a quiz on this part where you're just applying your rules of exponents with the number e, okay? First thing is reduce your number. A 2 out of 40 is really a 1 out of 20, okay? Now, if you need a calculator, I'm hoping you don't need a calculator for that, but you did need a calculator, you could take 2 divided by 40. It gives you decimal. I would prefer not having the decimal. Oh, and let me change my float back. So just so that you can see when you divide, it's really 0.05, but hit math, enter, and you're going to see it's 1 out of 20. Okay. And then most students did well on this in the quiz. Couple people, though, their brain told them to divide the exponents. We do not divide, we subtract our exponents. We take 10 minus 5, and we get a 5. Okay, we take the exponent at top minus the exponent on the bottom. Okay, for this one, you're going to take 7 and cube it. So I know that 7 cubed is 343, and then you're going to multiply. Okay, power raised to a power, this exponent, you do not cube. You take negative 6 times 3, you get negative 18, and then write your x. Okay, here we're taking the cube root. Cube root of 216 is a 6. And then you just need to realize this is the 1/3 power. So if I have e raised to 12x, and that whole thing is being raised to the 1/3 or the cube root, you're supposed to take 12 times 1/3, which is the same as taking 12 divided by 3. So that's where we get a 4x as my exponent. Okay, and then this one's super easy. You're supposed to, since you're multiplying everything, write e 1 time. Okay, bases have to be the same, and if the bases are the same and you are multiplying, you add your exponents. So add your 10x and your negative 2x, you get 8x, and then add the numbers, and you get 11. Okay, nothing hard there. This one, this section is just asking you to do really what we've been doing since chapter 1. We've been moving functions around. We've been reflecting them, moving them left, right, up, down. Same thing can occur when it's an exponential function with base e. It doesn't matter what the function is. If I need to reflect, I put a negative in front. Okay, so there's my reflection. And then since I'm moving to the left, that is where I need to go where my x is, my input. And since it's to the left, I need to have a +8 next to the x, okay? Can't be over here because then that all of a sudden would be a shift up 8. So make sure it's right there. If you want to, you can even put parentheses around it. So it's your exponent. And you can check that on a calculator. So if you really wanted to make sure, in fact, I will show this on a calculator real quickly. I can type in e raised to the x, that's my original function. If I want it to be reflected, I need a negative, and then e raised to the x plus 8. And I should see that here's my original. So it's going to curve up like that. And then over here, I'm going to see I actually reflected it, and I moved this over 8 units to the left. So I feel very good about my answer. Okay, I'll call that g of x. Okay, then a vertical shrink, the number is less than 1/3, it automatically makes it a shrink then. So I just put that in front. And then my last move is to translate up. So I need to make sure it's not with the x, it's a +1 off to the side. I promise you that's the answer. Again, you can check on your calculator. Okay. Let's take a look at the next page. So this page, we are finding the inverse. I like doing these problems. And again, it can be checked on a calculator. So this goes back to chapter 5 when I made you find the inverse of a linear situation. Well, these are a little bit more complex, but the rules are the same. So I switched my roles of x and y. That's the first move to find the inverse of a function. Okay. And then our next rule, our next move is to get y by itself. So since this is in parentheses, I can't add 5 yet. Okay, so I need to rewrite this, get rid of the log. So what this log is, it's base 6. So I could do this, I could exponentiate, that wipes that out. And we're really left with 6 raised to the x equals y minus 5. The log base 6 disappears when I do that, or apply the definition of log. 6 raised to the x power is y minus 5. And then the last move, add a 5. And there's my inverse. And again, you can compare that. You can type this in the calculator and see that they are inverses of each other. Okay? This next one, my y becomes an x. My x becomes the y, and now I'm going to isolate the y. So my first move is to subtract 6. So I need to undo this +6. I can send it over. And now my next move is to get rid of ln, which means apply the definition of a log. Ln is base e, okay? Logs are exponents. So if I put a little e here, that wipes that out, and I'll put an e on this side. That's that exponentiating process that helps us rewrite this. And as soon as I do that, I have its inverse. I solve for y. Okay, again, very easy to type that into your calculator and type this in and show that they are inverses of each other. Okay, here's another application. I may switch it up. On your test, I may finally do a growth. So the last couple of quizzes, I've been doing problems that are decay, but I know clearly it's a decay because my base is less than 1. So that's an easy point. But if on your test, all of a sudden I have 1 point something, then it's going to be growth. It's going to be a value greater than 1. Then this problem is not a 92% decrease. It's the difference between 1 and this number. So if I do 1 minus 0.92, I get 0.08, which is an 8% decrease. Okay, needs you to understand that. So then this, if you read this problem carefully, so on the test, we actually had it from the year 2000. Well, this rule now says from now. So current time. So currently, we have 85,000 people, okay, living in this district. So what we're going to then do is be able to show and not just use our calculator. We don't actually need to use a table of our calculator because we know how to solve these now. So if I want to know when our town of 85,000 people that people are moving away, it's decreasing every year. We now have the skills to solve that. Okay. And it's a very powerful thing in mathematics to be able to solve equations like this. So my base is 0.92. I want this number going. So since 85,000 is being multiplied, I can undo that by dividing. So we'll simply divide 85,000. So I'm going to take my calculator. Now it's going to be a decimal. I'm actually going to convert it to a percent. So 30,000, did that correctly, divided by 85,000. You get that. I'm going to hit math, enter, enter, because I'd rather deal with 6 over 17. Okay, so here's what we're solving. It looks goofy, but it's actually very easy to solve because we now know logarithms. Okay, that's the key. That's why we learn logarithms is so that we can easily solve an equation like that. So prior to it, we had to use a calculator. We had to just guess about when this will occur. But now I just apply the definition of log. Log, and my base is a 0.2 or 0.92. Again, the calculator could care less if that's a decimal. But then the number is 6/7, and logs are equal to exponents. So that's the answer I want. I want that answer. And the good news is that calculator will easily be able to tell us this. Okay. So prior to calculators, you had to look up these logarithms in a textbook and stuff. It was a pain, but they're all stored in our calculator. So I put my base, I put the number as 6 over 17, and it's going to see that it takes about 12.49 years. Okay, so given this pattern, we would expect our 85,000 people to become 30,000 people in about 12 and a half years. Okay, that's all we're doing. This problem we should be very familiar with by now. It's so easy. It's a continuous compound interest problem. The formula will be given to you. Okay, we dealt with compound interest problems, which the formula is a little bit more involved than this one. But on your test, I will give you, so A equals, I'll give you a starting amount. It would be nice to be able to take $45,000 to the bank and let it sit there earning 0.0375. Okay, some of you still are struggling with how to take a percent and convert it to a decimal. Okay, you got to do that correctly or you're not going to get the correct answer. And then I take this decimal and I multiply by the number of years. Okay, calculator does the work for us. We hit 45,000 second ln. There's our E. That's our base E. I raise it to the 0.0375 times 12. And we went around to the nearest penny. So at the end of those 12 years, my $45,000 now is $70,574.05. Okay. Again, if you wanted the calculator to round for you, change your float to a 2, and you would see that it would round properly to the nearest penny. Okay, 2 decimal places. Okay, that leaves us our last page. And then we're almost done. Okay, so we're 23 minutes into this, and I'm doing a lot of talking. So again, the test won't be quite as many questions as I'm going over right now, but it is important that you understand all these. We've seen this on a quiz. This is this formula for fruit flies being multiplied. So the formula is 33e raised to 0.5493 times the number of days. So in this case, I want to know, well, what happens if we let this go for 18 days? Once again, it's an application. Okay, I just want to make sure everyone knows where the E is on the calculator, second ln, and then put in your decimal. So it's 5493 times, in this case, 18. And then I'm just going to write 64,900. Actually, decimal, the comma doesn't go there. It's 649,467. Okay, and it's fruit flies. So this time I'm just rounding to the nearest whole number. Okay, I'm just dropping this part off. Okay, so I need you to see why it's 649,467 fruit flies. So lots of fruit flies from starting with 33. Let them go crazy. In 18 days, you're overwhelmed by fruit flies. Now, this question here, I like this. I like having students be able to tell me precisely when money is going to equal a certain amount. So in this case, we use that same formula, which I would have on your paper. It's A equals PE raised to the RT. This time, I want to know when we will have $2,000. Okay. I want my ending amount to be $2,000. I'm taking 1,500 to the bank, and we are told that we earn 0.0625, okay, 6.25% as a decimal. But what I want us to figure out is how many years? I don't know that, okay? In the past, we were forced to go to the y screen, type this in, maybe change our scale, and try to get as close to 2,000 as an outcome. Well, now we have the skills to solve this, okay? And it's not that hard. So get your base by itself. My base is in E. So I'm just simply going to ask the calculator 2,000 divided by 1,500. Okay, again, decimal, math, enter. I rather deal with 4/3. Okay, 4/3 E raised to this power. So now, to get rid of base E, it's an ln. So I just need you to realize I'm simply going to ask the calculator what the ln of 4 divided by 3 is. And once I do that, it's going to tell us what that answer is. And then our last move is to divide by 0.0625. So I'm going to ask the calculator now what the ln of 4 divided by 3 is. That's where the 4/3 is. It's really, you could also type in 2,000 divided by 1,500 if you wanted to, but it's simplified to 4/3. I get that decimal, and let me change my float. I didn't want to show you that this is actually an irrational number. It's a big, long decimal answer. So I keep that on my calculator. And then I divide by 0.0625. I divide by the rate. So 0.0625. And you're going to see my $1,500 can turn into 2,000 after 4.6, and it stays 0 years. That's what I want you to be able to solve, okay? And that's really the ultimate question, to be able to use our knowledge of logarithms to solve equations like this, okay? So again, talk yourself through how to undo things, how to get rid of base E. It's simply the ln of the number, and then we divide it by the rate, okay? So if you can do one of those, you could do any of them, and we solve that in our notes and stuff. So make sure you can talk yourself through that. The last two are just simply let the calculator do its job, okay? So for these last two graphs, all we have to do now, we should know about the shifts right away. My main thing is, since it's a logarithmic function, our domain is going to be restricted. I am not allowed to take the log of 0 and any negative numbers. So since this is a shift to the right, though, I'm not even allowed to substitute a 1 in. And we're going to see that when we type this into a calculator, 1's going to give us an error. So if someone came along and plugged in a 1 for x, I would be forced to try to calculate log base 2 of 0. And it's going to give you an error. You can't do the logs of 0. So all we have to do is type this into our calculator. So part of the skill is, do you know how to type this in? Let's clear the two equations that I had. I'm going to hit my math key. I'm going to scroll up to log base, and I'm going to put my base of 2. I'm going to have an x minus 1 in parentheses, and then I'm going to have a shift up to. So you need to realize it's shifted up to. You can see the calculator is 10th. It's a poor attempt because this goes down forever, okay? So draw this guideline. So draw the vertical guideline, part of the big idea assignment. They made you state that guideline. It's called an asymptote. It's x equals 1 for this example here. And when I go to my table, I'm going to see that I get errors for any negative. I get an error when x is 1. Okay, so we just have to gather a couple dots because that guideline definitely can help us. So here's my little table. We can easily plot 2, 2. I'll plot 2 up 2. And then I can easily plot 3, 3. So if x is a 3, it comes out to a nice answer of 3. Okay. And then I'll just do 5, 4. Now, some of these, now on your test, maybe they're all decimals so that you would have to estimate where the decimals are, but I should be able to go over 5, up 4. And you need to realize what this curve looks like. So it's going to continue to go up gradually. Okay, it's going to hit every single outcome going in this direction, and then it's going to go down forever. So it'll hit all the negative outcomes. So just draw a little arrow. You will never touch that guideline. You'll never touch x equals 1. You'll get very close to it. So just think how close you can get to an out or an input of 1 on the right side, like 0.000001. Okay, that would produce a negative outcome. But that's what I need you to be able to see so that you can see what the graph looks like. And then you need to be able to state the domain, which you can clearly see my x values have to be larger than 1. Okay, it could be 0.01, but it has to be when you plug in a 1. So don't have a little equal to. It can't be equal to 1. It has to be larger than 1. It could be slightly larger than 1. But then your range for all logarithmic functions is going to be R reals. Okay? So then real quickly, I have another situation. This time we're shifting to the left 6. So I'm going to have a guideline at -6, which will change my domain. So for this, it's an ln, base E. So it's still a logarithmic function. I type in x plus 6. I close the parentheses, and I add 4. So it is a shift up. I can see what the graph looks like, but I know it's over here now. So it's on this side of my guideline, which is x equals -6. And again, that guideline helps us state my domain. Okay, the range is all reals. Okay, now on your last quiz, I gave you exponential functions where the domain was all reals and then our range was restricted by a horizontal guideline. So again, these are inverses of each other. So you need to let your brain process that. So when I go to my table, I need to gather some dots. So I'm going to go to where I see my error, and from there I can plot the point -5, 4. So I can go over here to -5 and up 1, 2, 3, 4. There's a dot. And then I'm just going to estimate, so I'll go to 0. So when x is 0, you're about 5.79, which is close to a 6, so just slightly below a 6. And just realize those two dots are really all you need, because I need you to realize it's a curve that will pass through those dots and then go down. Okay, it's going to go down, getting closer and closer to that vertical guideline. And then going to the right, it slowly increases. It's going to take a while to start getting some really large numbers. Okay, so it's just slowly going up, but that is exactly what you have to be able to do to be able to graph a logarithmic function. Okay, so hopefully that makes sense, and hopefully you understand all 29 problems. So that took me 34 minutes to babble on about how to do these problems, but I'm hoping if you were struggling, it makes sense. And then go back to your notes, try some of the same problems again. Go back and do some of the extra practice. Okay, remember, you have an ebook. You can look at examples in our chapter 6 from Big Ideas. Go back and look at some of the big idea problems that I gave you. Okay, you can reopen up assignments that you already submitted and see how you answered those questions. All that work, looking at your quizzes. So if you made mistakes on the quizzes I gave in chapter 6, learn from it so that you can do well on this Chapter 6 assessment. Okay? Thanks for watching. That still was under 35 minutes.